This lecture is about the addition and subtraction of radicals. So for this lecture, we have two objectives. First, we are to define and illustrate what similar radicals are. Then, after defining what similar radicals are and knowing more about them, we are now ready to perform addition and subtraction of radicals. Okay, so this is a very important concept, similar radicals. Similar radicals. Similar radicals are defined as radicals with the same order or index. Remember, if I have a radical nth root of a, we call this one the order or the index of the radical. And same radicand. So, in this example, a is called the radicand. That is what a similar radicals are. That's what similarity means. Same order and same radicand. So, for example, I have here three sets of radicals. 6 is square root of 2, 5 square root of 2, and x squared square root of 2. All of these radicals has an order of 2. Remember, if it's not written, it is implied that the order is 2. So, for all of this, n is equal to 2. And as you can see, the radicands are also equal to 2. So, these three values has the same order and the same radicand. Therefore, they are similar radicals. For the next set of values, another set of values, we have 5 cube root of 25, 6 square root of 3, and 7. This radical has an index of 3 and a radicand 25. This one has an index of 2 and a radicand equals to 3. And this value, 7, doesn't have a radical at all. This is not a radical. So, we say that these are the similar radicals. They do not have the same order or index, and they do not have the same radicand. They have different orders and radicands. So, they are the similar radicals. Now, you know what similar radicals are. We can now proceed with the addition and subtraction of radicals. It's a two-step process. First, we convert to similar radicals, and then we can perform addition and subtraction. So let us have examples about addition and subtraction of radicals. We have here square root of 40 minus square root of 160 plus the square root of 90. 40 can be rewritten as 2 squared times 10, and 160 can be rewritten as 4 squared times 10 plus square root of 90 can be rewritten as square root of 3 squared times 10. Now, using one of the properties of radicals, I can rewrite this as the square root of 2 squared times the square root of 10 minus the square root of 4 squared times the square root of 10 plus square root of 3 squared times the square root of 10. Because this is an index 2 and an exponent 2, we can remove those. That is our first property, if you still remember. So this becomes 2 square root of 10 minus 4, the square root of 4 squared is 4 times square root of 10 plus the square root of 3 squared is 3 times the square root of 10. If you notice, I have converted the values into similar radicals. All the radicands are equal to 10. And all the indices of these radicals are 2. They are all square roots. So I can now proceed with the addition and subtraction. I just consider the square root of 10 like a variable. I can, let's say, let x equals the square root of 10. This can be rewritten as 2x minus 4x plus 3x, which simplifies to 2x minus 4x plus 3x. This simplifies into x. And x is square root of 10, so the answer is square root of 10. That is the answer. We simply add the coefficients of the radical, of the similar radical. 2 minus 4 plus 3 is equal to 1. 1 times the square root of 10 is equal to square root of 10. So, for another example, we have 2x square root of xy plus square root of x cubed y plus square root of 4x cubed y plus cube root of x raised to 4 y. Now, I can rewrite this equation as 2x square root of xy plus, this one is x squared times xy plus, this here becomes 2x squared times xy, 2 squared, I'm sorry, that is 2 squared, so that becomes 4 times xy plus cube root of x cubed times xy. Now, proceeding with our step, this becomes, so let me rewrite this, 2x xy plus, this becomes square root of x squared times square root of xy plus square root of 2 squared x squared times the square root of xy plus cube root of x cubed times the cube root of xy. So further simplification leads to 2x square root of xy plus the square root of x squared is x square root of xy plus the square root of 2 squared x squared is 2x. So we continue with the simplification. X cubed, and taking the cube root of that, we get x times cube root of xy. If you notice, the first three terms are similar radicals. They have the same radicands and the same indices, which are all equal to 2. This one is dissimilar from these three. It has an index of 3. Although the radicand is also xy, the index is not equal to 2. So we cannot add this up to this 3. But we can add this 3. So 2x plus x plus 2x is equal to 5x. So this becomes 5x square root of xy. And don't forget this one. Plus x cube root of xy. So this is our sum and our final answer. In order for you to practice, here are some exercises. You just need to perform the indicated operations. These are just additions and subtractions. So remember, convert first to similar radicals before performing the indicated operations.